Today we're going to be talking about Unit 8, Lesson 4, which is inscribed angles. Now, an inscribed angle is an angle whose vertex is on a circle and whose sides are chords that are on the circle. So, if you see here, an inscribed angle would be angle ABC because the vertex is on the circle, so angle B is on the circle. And then your chords BC and your chord BA are also on the circle. Now the intercepted arc that is in between your inscribed angle is arc AC. Now, your intercepted arc is the arc that's inside of the inscribed angle and with the endpoints that are on the angle. So if you can see, angle ABC, the intercepted arc AC is inside that angle. Now, what are the angles versus the arc? Now, angle ABC is half the intercepted arc, and the intercepted arc is twice as much as angle B. So let's go down here to this diagram. It says if the vertex of the angle is on the circle, then the angle is half of the measure of the arc, and the opposite. The arc is twice as much as the angle. So, example A says, find the measure of the arc. So it says, find the measure of the arc, and we have arc SQ. Now, if my angle SRQ is 90 degrees, then my arc is twice as much. So 90 times 2 is 180 degrees. So arc SQ is 180 degrees. Now example 2 says find the measure of arc ZX. So here we've got ZX. Now if my angle is 115 degrees, then my arc is twice as much. So arc ZX is 115 times 2, so my arc ZX is 230 degrees. C says find the measure of the inscribed angle. So now it gives us what the arc is, and now we need to find the angle. So it says that arc NP is 100 degrees, so my angle NMP is half my arc. So half of my arc is 50 degrees, so my angle NMP is 50 degrees. Okay? Now, when we compare the measures of the inscribed angles, let's look. So, it asks us to find the measure of angle ACB, angle ADB, and the measure of angle AEB. Let me go ahead and I'm going to make it a little bit bigger so we can see. Now, if you look, the angle ACB is the arc that's inside is 60 degrees. Now, let's look at angle ADB. It also shares that arc AB, which is 60 degrees. And then we have angle AEB, which also shares the same arc, which is 60 degrees. So that means that angles C, D, and E are all the same, and they're half the arc. So angles C, D, and E are all 30 degrees. Okay. And in example 3, it asks us, find the measure of the arc ADC. So A, D, and C. So let's look. What angle is inside that arc? Well, that's angle ABC. And angle ABC is 90 degrees. So arc ADC is twice as much. So the arc is 180 degrees. Now let's look at example B. It says, find the measure of arc AC, and here is arc AC. So, if our angle is 70 degrees, then our arc is twice as much. So 70 times 2 is 140 degrees. So arc AC is 140 degrees. Now let's look at example 4. Remember what I told you up in the beginning. You can have multiple angles that share the same arc. That's going to mean that all of those angles are going to equal the same. So let's look at example 4. It says, it is given that the measure of angle E is 75 degrees. So I went ahead and I filled in angle E, which is 75 degrees. It says, what is the measure of angle F? Well, let's see. Angle E, so GEH, the inside arc is GH. Now let's look at angle F. Angle F also has the same arc. If they share the same arc, that means their angles are also the same. So, because both E and F have the same arc, angle E and angle F are also congruent. So, angle F is also 75 degrees. Okay. Now, example 4b says, it is given that the measure of angle B is 44 degrees. So what is the measure of angle C? Well, let's look. If angle B is 44 degrees, means that the arc, the inside arc, is AD. Well, let's look at angle C. Angle C also shares the same arc, which is AD. Remember, if they both share the same arc, then both of their angles are also congruent. So both angle B and angle C have the same arc AD. Therefore, angle B is 44 degrees and angle C is also 44 degrees. Now let's go down to this diagram here. It says, find the measure of angle ABE, angle ACE, and the measure of angle ADE. Now I'm going to go ahead, I'm going to show you, here's also the diagram here. Now, if you notice, angle ABE, angle ACE, and angle ADE, they all share the same arc, which is 90 degrees, okay? So they all share the same arc. Therefore, all three have to be congruent. And if their arc is 90 degrees, then their angles are half. So angle ABE, angle ACE, and angle ADE are all going to be 45 degrees because 90 divided by 2 is 45 degrees. Now let's look at example 2. Example 2 is a little bit complicated, so I'm going to walk you through it. Now, I'm going to go ahead, I'm going to show you the exact diagram. So here it says we're given that the measure of arc BD is 164 degrees. So that's this arc down here. We know that it's 164 degrees. So we want to find what is the arc of BAD. Now, we know that an entire circle is 360 degrees. So before I even find x degrees, z degrees, and y degrees, I want to fill in all the information that I know. So if I know that arc BD is 164, I'm going to subtract that from 360 to find the arc of BAD. So I went ahead and did that. So 360 minus 164 is 196 degrees. Now, I also know that AC is my diameter, which cuts my circle into half. And because I have these chords here, I also know that these two, arc AB and arc AD, are congruent. So I divided 196 by 2 and I got 96. So BAD is 196 degrees. So 196 divided by 2 actually should be 93. So can you please change that? It should have been 93, not 96. Okay, so 196 divided by 2. So let's do that. 196. So go ahead and do that on your paper. 196 divided by 2. So 196 divided by 2 is 98. So it should be 98 degrees, not 96 degrees. So AD and AB is actually 98 degrees. Okay? So if these two are 98 degrees, we know that BD down here is 164 degrees. So I divided, and we also know that arc BC and arc DC are congruent because again, the middle line here cuts it into half. So I can say that DC is 82 degrees and BC is 82 degrees. So then what I'm going to do, I need to find x degrees. So I went ahead and I made my angle here. Now let's look at our inscribed. If you notice, x degrees vertex is on the circle. So it's an inscribed angle. So I want to look and see, where's my arc? My arc goes from A, B to C. So from A, B to C. Now remember, we changed this. This shouldn't be 96. It actually should be 98 degrees. So I'm going to go ahead and I'm going to add 98 plus 82, and I'm going to get 180 degrees. So x degrees is 180 divided by 2, which is 90 degrees. So my x degrees is going to be 90. And that means that y degrees is also 90 degrees, because this angle here goes from A, D, is arc A, D, and C. And arc A, D, and C and arc A, B, and C are congruent. So if x is 90, so is y. Now let's look at z. Z goes from A, C, and D. That's only this 98 degrees here. So I'm going to take 98 and I'm going to divide that by 2, and z degrees is 48 degrees. Now we're going to go ahead and we're going to talk a little bit about using the properties of inscribed angles to help us find the angles in a quadrilateral. So a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. That means, supplementary means that the opposite angles add up to equal 180 degrees. So the measure of angle D plus the measure of angle F has to equal 180 degrees. And here the measure of angle G plus the measure of angle E has to equal 180 degrees. So let's go and find our examples. So the first example says, find the value of each variable. So let's go ahead, and it says opposite angles are supplementary, which means opposite angles add up to equal 180 degrees. So angle E plus angle Y has to equal 180. So 120 plus Y is 180 degrees. So that means Y has to equal 60 degrees. And then angle F plus angle D have to equal 180. So 80 plus Z is 180. That means Z has to equal 100 degrees. And finally, let's look at the second example. The second example says, find the variables. So remember, angle R plus angle T are going to equal 180, and angle U plus angle S is going to equal 180. So I said x plus 85 is 180. You subtract 85 from both sides, and you get x is 95 degrees. And then we get y plus 80 is 180 degrees. You subtract 80 from both sides, and you get y is 100 degrees.